Hi, I am Ayan Kumar Bhunia from SketchX Lab of University of Surrey. I would be presenting our work Sketch Less for More, on-the-fly fine-grained sketch-based image retrieval. Fine-grained sketch-based image retrieval, or FG-SBIR, aims to retrieve a particular photo instance within a gallery, for a user-given sketch query. But, there is a problem: people can't sketch. More specifically, drawing a complete sketch is slow compared to clicking a tag or typing a search keyword. Furthermore, users often perceive themselves as someone who can't sketch, worry about receiving inaccurate results. In this work, we intend to break these barriers by taking a view of less is more, and propose a new fine-grained SBIR setup. While the existing frameworks require a complete query sketch to be available before feeding into the model, our framework starts retrieving as soon as the user starts drawing, with an ultimate goal of retrieving the target photo with least number of strokes possible. In on-the-fly setup, users can usually stop early as soon as their goal is retrieved. This thus makes the sketch-based retrieval process more natural, as those inexperienced at drawing can retrieve their queried photo based on the easiest strokes possible, while requiring fewer of the detailed strokes that are harder to draw correctly. In most cases, we can retrieve with nearly 30% less strokes. In spite of significant progress, existing FG-SBIR methods struggle to perform well on incomplete sketches for on-the-fly retrieval. Because of mostly triplet loss-based training, those frameworks are not fundamentally designed to handle incomplete sketches. Imposing triplet loss on incomplete sketches is more likely to give a noisy gradient. Lastly, there is no specific mechanism that can guide to retrieve the photo with minimal sketch strokes. Triplet ranking loss-based learning does not account for the temporal sequence nature of the sketch input. Our reinforcement learning-based framework optimizes the rank of the target photo with respect to a sketch query over a complete sketch drawing episode. Therefore, representation learning is performed with knowledge of the whole sequence. Once the triplet loss-based baseline model is trained, we fix the photo branch, and fine-tune the sketch branch using reinforcement learning. The sketch branch acts as our agent in RL framework, based on a stochastic continuous Gaussian policy, where action generation is represented with a multivariate normal distribution. Please note that the final embedding layer Gmu is trainable and rest remains fixed during RL-based fine-tuning. We have two reward functions to train the RL framework. By calculating the rank of the ground truth photo at each time instant t and maximizing the sum of 1 upon rank t, over a complete sketching episode, we aim to retrieve the correct photo as early as possible. This is our local reward. On the other hand, a global reward aims to circumvent the problems related to irrelevant sketch strokes, and thus provides us with a more consistent rank list during the retrieval. This is designed via monotonically decreasing constraints on normalized Kendall-Tau distance between every two successive rank lists over a sketch drawing episode. Finally, we train our reinforcement learning-based framework via proximal policy optimization method. We use top Q accuracy, and for early retrieval, we consider the area under ranking percentile versus percentage of sketch, and 1 upon rank versus percentage of sketch. A higher value of the mean area under these curves signifies better early sketch retrieval performance. There has been no prior work dealing with early retrieval in SBIR. Hence, we design a few baselines. Baseline 1 signifies a basic triplet loss-based model. For baseline 2, we train a standard triplet model, but use all intermediate sketches as training data, so that the model also learns to retrieve incomplete sketches. In case of baseline 3, we design 20 different models for the sketch branch to deal with a specific percentage of sketch. Baseline 4 is an alternative way to approximate the non-differentiable objective functions such as ranking. Illustration of proposed on-the-fly framework's efficacy over a baseline FG-SBIR method. Our RL framework outperforms other baselines by a significant margin as seen from the both table and plots. While using our local reward achieves an excellent rank in early rendering steps, we notice that the rank of a paired photo might worsen at a certain sketch rendering step, later on, as illustrated shown in this figure. As the user attempts to convey more fine-grained detail later on in the process, they may draw some noisy, irrelevant, or outlier stroke that degrades the performance. Our global reward term alleviates this issue to a significant extent. Additionally, we explore different RL methods and different alternative reward design choices to validate